Hello everyone, my name is Masagazi Ruth and my colleague is Matovu Abdukarim, and we've been working on this divorce project with a project title, Reinforced Knowledge Distillation for Divorce Prediction with Sparse Self-Supervised Learning, and the model product, we called it a Marriage Insight Predictor. So we are looking at a problem statement of divorce. And since divorce is rampant both globally and in Uganda, and by definition, it is the act by which a valid marriage is dissolved, usually freeing the parties to remarry. So we are dealing with the problem of divorce, and we want to predict the likelihood of divorce happening between married couples. And yes, there are models that have been put up by different researchers, different machine learning engineers, but these models are not predicting divorce accurately, and they are facing challenges like imbalanced data, high dimensional features, and complex nonlinear relationship. So, our work proposes a machine learning framework that combines reinforcement learning, reinforced knowledge distillation, self-supervised learning, graph neural networks, and ensemble learning plus sparse learning to create a clear and scalable divorce prediction model. And it is going to be tackling issues like overfitting, nonlinear relationships, and sparse data. So the proposed solution, as I said, it is going to combine various machine learning techniques. The existing models usually use one technique. So now we are combining multiple techniques to bring out the robustness of the model in the prediction of divorce. Yeah. So these are the related works. There is Al-Hunaim, who invented the random forest and performed the divorce prediction using a random forest model on the Saudi Arabia dataset. And he was considering features like communication, conflict. Yeah. So he got an accuracy of 91.66. And then the gaps in his works were limited scalability and regional bias, since he only used the data of like 300 couples basing on Saudi Arabia, not like worldwide. Then another one is for Zhang. He used ensemble learning to combine both SVM and support vector machine and neural networks. And he used a data set of Chinese marriage records with 500 samples. And he considered features like emotional stability between the couple, then finances, and his model improved marital stability prediction. And then the gaps in his work were there was lack of feature selection, and then high computational cost. Another one is Gupta and Kumal. They use the artificial neural networks using the UCI divorce predictors dataset, which has 54 attributes and 170 instances, and they got an accuracy of 89%. They got gaps were they used a small data set and there were risks of overfitting. And then another one, the last one is Yilmaz. He used naive bias on a Turkish marriage dataset of 200 samples and also focused on emotional connection and the arguments between the couples. And the gaps, he had a small dataset of only 200 samples. Yeah. So our problem statement, we have the domain application statement, which is the rising rates of divorce that are causing significant emotional, financial, and societal impacts. It impacts also the children of the divorced couples, usually impacting them with stress and depression. Yeah. So the existing models are inaccurate and not scalable, as I say, due to the reliance of linear models or subjective assessment. So there is need to come up with a data-driven solution that can scale and predict divorce accurately, such that there are timely interventions before divorce can occur. Then our computational problems, we have a class imbalance where divorce cases are fewer than stable marriages, like in the UCI divorce predictors dataset. That one, it has as I said, it has 170 instances where 86 are not divorced and then 84 are divorced. For this, it only has class imbalance of 2, but other data sets exist that have a class imbalance that can be over above 10, and this is going to bring the model to be able to bring the model to have bias and fall more or skew its results and predictions to the side of no divorces. Yeah, so another problem is a highly dimensional relationship data, which consists of multiple interdependent features that can lead to overfitting and increased computational efficiency. Another one, the complex relationship dynamics. The relationship dynamics are complex. So the use of the linear models like the linear regression, random forest, these cannot bring out the prediction well. So we are going to we used graph neural networks, and we actually used the graph convolutional network model to intricate the dependencies to represent the relationships, the features, the relationships between features such that the model can predict divorce basing on how the different features are relating to each other. Yeah, then some research questions and objectives. I wanted to develop a reinforced knowledge distillation model for divorce prediction, to evaluate the performance of the models, to improve model interpretability, generalization, and computational efficiency, and then to integrate self-supervised learning, sparse learning, graph neural networks, knowledge distillation, and reinforcement learning into one framework. Research contributions. So we started off by building 8 machine learning models, and we evaluated their performances to get the best 2 and the worst 2. Then we built the first integrated model combining self-supervised learning, as we say, sparse learning, graph neural networks, knowledge distillation, and reinforcement learning to form a reinforced knowledge distillation framework for accurate divorce prediction. So the RKD model that integrates all these machine learning models was one of the best 2 after the GCN taking the first part and it taking the second part. Then we conducted a thorough performance evaluation of our model against the existing benchmarks, showcasing superior accuracy, precision, recall, and F1 score. We deployed the chosen best model, which was the graph convolution network model, on render, and then that captures intricate relational dependencies within the divorce data, modeling the dynamics interaction between the features, as we said. And then we integrated explainable AI in the GCN model and the RKD model, and also in the logistic regression model and the random forest model. Sorry, and the SVM. So after that, we developed a simple user interface of the GCN model such that users can interact with it. We used Django, and then we presented our product to Unipod, Makerere Unipod, and then the Makerere IP office, and they are working on protecting our work, and then some funding. Yeah, so this is the methodology of this and the system architecture. So first we input the divorce predictors data set, then we perform data processing steps, data cleaning, dealing with outliers, missing values. Our data set did not have any missing values. And then we standardized, we standard scalar, we standardized that, made the mean 0 and standard deviation 1, such that all the features are on the same scale to reduce bias. Then we made the KNN graph. Then we split the data into training and test, 80% testing, training and 20% testing. And then we train the models. We train, say, 8 models, as I say, the SVM model, logistic regression, random forest, KNN, CNN, GAT, then GCN, and then the RKD model. And then after that, we evaluated their performances to compare them and get the best 2. And then we put after training the model, we fed it into the prediction system to see how it is predicting, whether it is giving the correct values, target values, and then we created visualizations, then metrics, and then we got the results. Yeah, and then our data set was, we used the divorce predictors data set from the UCI machine learning repository, and it had 54 attributes and 170 instances, like 170 couples participated. So the class Yeah, as I said, 84 divorces and then 86 not divorced. Then these are some of the results that came out from our EDA when we were trying to understand the data set we are working with and then cleaning it, preparing it before we can train the model. And then we used feature importance to know which features are more important than the others, and yeah. Then this is the distribution of divorce cases. These are the no divorces, they are 84, and then divorced. No divorces, they are 86, and then the divorce, they are 84. Yeah, those are some of the other results. Yeah, then I said we implemented explainable AI in the best two and the worst two models. So we created to create transparency on why these models are performing the way they are performing, why they are making these predictions, why the model is predicting divorce, maybe to know which feature is causing it to predict divorce and which features are causing it to not to predict divorce. And then we use sharp and line techniques. Yeah, and we discover that some features influence predictions more than others, and negative features skew the predictions to the divorce, while positive features skew the prediction to no divorce. Yeah, those are some of the XAI results. These are sharp summary plot where attribute 40, 26. These impact the prediction of the model. It's the same here now. This is the waterfall model. Attribute 3 skews the model to predicting divorce. Then 39 and then 40. And then this is the explainable AI. We used Lime. Yeah. Then feature importance. And then model selection, as I said, we trained 8 models, then evaluated them using accuracy, precision, recall, F1 score, training rate, and learning rate. And then we focused on generalization and correct predictions and no overfitting. And the GCN model was chosen due to its consistent accuracy of 92%, recall of 90, to also then F1 score was outstanding precision, and also its learning rate was better than that of the others. Yeah. Then the RKD ranked second. It had a good generalization, but a weaker prediction. When we put it to predict the actual values, it was giving different target values. Yeah. Then we deployed the GCN model that we chose on using Django, and yeah, then we deployed it on Render, and it can be used in counseling apps. It can be used in legal firms, then by marriage counselors. Yeah. So this is our model that we came up. This is the product. Yeah. We move on. I will show you a demo with time. Yes, so this is let me show you a demo of our product. So it is a divorce prediction model, and it uses a scale of 0 to 4, where 0 means never, 1 means rarely, 2 means sometimes, 3 usually, and then 4 always. So for negative questions, lower lower scores are better for negative questions. So if the question is negative, we should give it a lower of maybe 1, 2. But if we give it a big one, then it means that negative impact is going to lead to divorce. Then for positive questions, higher scores are better. So as we said, our model has 54. Sorry, data set has 54 questions, and these 54 questions were questions that were asked to the 170 couples. Yeah. So now this is the model, this is the product we created, the user interface we created. So if the couple answers the questions according to their situation. So we have one, we are compatible in sharing daily chores and responsibilities at home. If it is true, yes, this is a positive one. If I choose a higher one, then it is good. Then if it is not true, they can lower to 0, 1, 2, as I said, the scale goes up to 4. Yeah, you can see that 4 changes here, then 2. Yeah, so the couple goes on to adjust, and then after that, they press predict. And then these are the prediction result. Low risk of divorce, and then the probability of divorce is 48.99, and then the probability of staying that together is that. So you can see that as you keep on adjusting, the predictions are going to change due to the corresponding responses of the users of the products. Yeah. So you can see maybe if the negatives are many, then of course the probability of divorce is going to be high. Yeah, so that is the demo of our, and we're going back to the slides. Yeah. Mhm. Yeah, so conclusions. We successfully developed the reinforcement model, although it did not, it's not the one we deployed, but we are going to work on it so that we keep on fine-tuning it until it is the best one. Then we successfully built and deployed the GCN model, integrated XAI in the GCN model. Then we integrated the model into a Django-based API. Then we ensured stable deployment through continuous monitoring, version control. And then we put up a product to be protected by the IP, intellectual properties, Makerere University. Some of the limitations, we had a small data set, and then creating a Docker image and installing Docker on our machines, which was very heavy on the PC, and it was time consuming. And even in the early stages of building models, the models could take up all the resources. Say you're using VS Code, it could take a lot of time and you're waiting for only this model to build. Yeah, so we shifted to Google Colab and Kaggle online. Then we had, then limited counseling recommendations after the prediction. Not many people, we did not get people to try our product to get much feedback. Then some XAI techniques did not work well on the different models. So we had to try out different techniques, which was time consuming. Then the next steps, we are going to expand the model to larger and more diverse data sets to improve generalization across different populations. And then we're going to develop a real-time divorce prediction mobile app using Flutter, because for now we just have a simple user interface using Django API for broader access and usability. Then we are going to optimize the RKD framework further for even faster, more lightweight predictions. Some of the acknowledgements. So we would like to acknowledge and express our sincere gratitude to Mr. Dr. Galiwango Marvin, our advisor, our lecturer, for his continuous support, patience, and guidance through this project, and encouraging us not to give up. Yes, things might be hard, but you have to move on, have to push, never to give up, and never to lose hope. That's what he kept on saying. So thank you, Mr. Galiwango Marvin. And then we would like to thank Unipod, Makerere University, for providing mentorship, technical support, and innovation resources for the development of this work. And special thanks to my colleague, Matovu Abdukarim, for the insightful discussions and the contributions. And yeah, we are very grateful to Makerere University for providing the necessary resources. And finally, we extend our appreciation to everyone who helped in any way, big or small, in the completion of this work. I remain Masagazi Ruth. That is our divorce prediction project. Thank you.